Alright, so let's do some examples where we're looking at area and volume. I like to do these together because this is how the AP exam puts them on the test typically in free response. But in the multiple choice, it could be one or the other. So for each of these examples, we're going to practice doing the integral to find area as well as the integral to find the volume when you're revolving. So in each case, I'm going to start and I'm going to put a sample point. Now it's a little bit simpler with the area, and I drop this. So you can now see you have a rectangle. Its width is an X. Its height is a Y. So the area of that slice is Y dx. It's going to go from 0 to 5. So my volume is 0 to 5 of the quantity 5 minus x in x. Now, I'm going to integrate that as one whole thing. So, I'm going to gain a power, and then don't forget the chain rule because you need a negative sign or you've got deep, deep trouble. And we're going to go from 0 to 5. Okay, so minus 1/2. 5 minus 5 squared, I hope that's still 0, minus 5 minus 0 squared. That's a whopping 0. This will be a minus 25, so this will be 25 halves square units. Now, we need to get you practicing using your calculators like you're going to use them on the exam. I've been pre-upping some of this. So, here's this. One of the things you are expected to be able to do is, using your grapher, evaluate an integral. And my lower bound, I'm just going to type in 0. My upper bound. And there's my area. Oh, oops, it's the wrong one. Let's just add a page. Okay. We're in calculus class. We need an integral. We're going to go from 0 to 5, and I'm just going to type this in because I can. Notice it knows to put a parenthesis there. Okay. Now, we're going to go back and we're going to take a look at this. And now we're going to take that region and we're going to revolve it around the x-axis. So the first thing I would like you to do is sketch in the reflected area. I didn't give you enough room on the grid. I'm so sorry about that. This is an XY. So you just draw on this segment and then revolve it. You get the illusion. It looks like a disc, but in reality it's a little cylinder. And draw a few more in so you get the illusion of volume. It's a right circular cone. And I'm integrating an x, so the height is an x. The radius is y. So the area of this cross section is pi y squared in y. Okay, which is pi, and since I'm, well, let me, x, not y squared. However, that's the same thing as pi times x minus 5 squared. Okay, so the slice is the area of the cross section times its height. That's the volume of the slice. And this is pi x minus 5 squared in x. So my volume will be the integral from 0 to 5. Don't forget the pi on the outside like Mr. Isaac. Using algebra, I was able to make that more friendlier. I'm going to use the power rule and look at this as a composition. So this will be pi thirds x minus 5 cubed from 0 to 5. Now we're going to do the same thing we did before. This time I'm going to take a few liberties. I evaluate this at 5. 5 minus 5 is 0 cubed. Wait a second. second. I have an algebra mistake somewhere in here. Hold on. Okay. I see what I did. I dropped a sign. So this will be minus. But 0 minus 5 is negative 5. Negative 5 cubed is 125. So this will be 125 pi. Don't forget to divide it by 3 cubic units. Now, let's go do this on our calculadora. So, you're going to notice that, I forgot I need to put the pi. I forgot to put pi there. Okay, but Mr. Isaac, all right, well, hold on 1 second. There we go. So, the area underneath this parabola from 0 to 5 is the volume of the solid of revolution. Think about that. That's an application of volume. Now, when you do this here, okay. Oh, no, I don't want. Oh, come on. Let me get the. Okay. Hold on. I got to change this number. All right. There we go. Okay. But now notice, because it only gives you 3 decimal places, I had to add decimal places. Now, you will see there it should be right there. There's the integral that we just did. Okay, now I'm going to copy this and I'm just going to switch this so that you can see it works. So as you can see, very robust example, a good example